We have here a function of x, and what we're going to do is we're going to take the derivative of this using the power rule, which is n times x to the n minus 1 power. So when I take the derivative of this, I'm going to do it in parts, treating each one of these as a separate problem. So for the first one, n is 3. I bring it to the front, so this becomes 3 times 2 times x, and I reduce the power by 1. That becomes a 2. I bring down the plus. The 2 comes to the front, and I reduce the power by 1. And then over here, the power is a 1. So when I bring the 1 to the front, it's just going to leave the number. Then reducing the power gives me x to the 0, which is a 1. So this would be 5 times 1. And then finally, when I have plus 2, the derivative of a constant is 0. So that just falls out. So our final answer over here, 6x squared plus 8x plus 5. Now, when we integrate, we want to do the exact opposite of the power rule. So what we want to do is we have x. We want to increase the power by 1. And since I had brought down the original number to the front, what I'm going to do is, instead of multiplying by n this time, I'm going to divide by this n plus 1. So this is actually the formula that we're going to use. So let's try it out on a few. So if this is the symbol for integration, so if I have x to the 4th power dx, I want to integrate this. So using this rule over here, so I begin with x, I increase the power by 1. This gives me my n plus 1, and then I'm going to divide by that n plus 1. So since I'm starting with this, and the derivative of a constant is 0 and doesn't come down, this may have had a constant, so we just put plus c here to indicate that a constant may have existed. Here we're asked to integrate 4x to the 3rd power. When you have this coefficient, you can just move it to the front. And then I'm going to do the integration for x to the 3rd dx. So moving over here, I bring over the 4. And then when I integrate this, I'm going to increase the power by 1, which is a 4, and then I'm going to divide by 4. And since I don't know if there was a constant involved in here and the constant was a 0, I just put the plus c. We now want to simplify this. 4 divided by 4 is 1. So the answer here is x to the 4th plus c. Now, here we're asked to integrate a radical. The first thing that I want to do is I want to put this in the form where it has a fractional exponent. So over here, I'm just going to rewrite it as x to the 1/2. The 1 is underneath. The index here, when it's not written, is a 2. So this is the 1/2 power dx. Now integrating this, let's just follow the rules. I start with the x. I increase the power by 1. 1/2. I change the 1 into 2 halves, so I have 3 halves. And then I'm going to divide by 3 halves. And with this here, if I multiply the top and the bottom by 2/3, well, this will cross simplify to give me a 1 in the denominator, and this 2/3 will come to the front. So our final answer is 2/3 x to the 3/2 power. And if you want to put this back in radical form, you have 2 x to the 3rd over 3 plus c. And I did forget the c on this line and on this line. This next problem is essentially 3 problems in one. You're going to integrate each part individually. So I'm going to bring the 2 to the front. The 4 to the front. And for the 6, I am going to leave that for the next step, but this is just going to be an x and dx. On the next line, I'm going to put 2. Now I'm doing the integration. I increase the power by 1 and divide by that. Plus 4. I increase the power by 1 and divide by that. And over here, I increase the power by 1. This is a 1 in front of the 6, so that's x to the 0. I increase the power by 1. We have 6x. And we don't know if there was a constant or not, so we just put plus c. Finally, This here can be simplified. 2 goes into itself once and 2 goes into 4 2 times, which simplifies to just 2x squared. For these next two problems, pause the video and then check your answers against what I get. So for this next one, treat it as two separate problems. So I'm going to bring the 4 to the front. Then we'll integrate x to the third plus 3 to the front and integrate what is essentially x to the 0 dx. On the next line, I'm bringing down the 4. I'm going to increase the power by 1. I'm going to divide by that plus 3, bring the power up by 1, which is x to the first power, and I divide by that, but I don't have to go through all that, so it's just 3x. I don't know if there's a constant, so I just put the plus c. And this can be further simplified over here, so this first term is just going to be x to the fourth. So on this last one, we'll again treat it as, in this case, 3 separate problems. So I have a coefficient, so I'm just going to bring that down. I increase the power by 1 and divide by the new n plus 1. These will simplify. And over here, I'm going to have the 4x. This is going to be the 1/2 power, so I make that 3/2 power. And then I divide by 3/2. And then the 1 is just going to be 1x. I don't know if there was a constant, so I put the plus c there. Now I'll just simplify. 3 divided by 3 is 1, so the first term is just x third. For this second term over here, instead of dividing by 3/2, I can multiply the top by 2/3. And when I do that, this entire thing becomes 8/3. And that's it for the simplification. One final distinction that I'd like to make is the type of integration that we were just doing, taking this form, where there are no numbers over here near the integration symbol. With no numbers here, this is actually called an indefinite integral. The indefinite integral, when you do get a final answer, is going to be in the form here where you have a variable. Another type of integration that exists is one that looks like this. And in this form, you see that there is a 1 and a 3 that looks like a subscript and a superscript. And this is giving you a boundary where you're going to eventually use this to find area under a curve.